Welcome to this video lecture on the subject transmission lines and antennas. So in this lecture we are going to discuss about single stub matching. So first of all, what is matching network and what is the purpose of matching network of a transmission line? So consider a generator with impedance generator impedance is Zg and the feed line is connected between the source and the load, and in between we have a matching network. So where ZL is the load impedance value, and what is the purpose of matching network? So for the effective power transmission from the source to load, we need a matching network. So because for the sum load, the impedance will not be matched with this characteristic impedance, so we get some reflection from the load. So to avoid the reflection and for efficient power transfer, we need matching network. So when a high frequency line is terminated in its characteristic impedance or not, it is operated as a smooth line. So under such conditions there will be no reflections, maximum power is delivered to the load and increase the efficiency. So in practice, the load such as antennas do not provide resistances equal to R naught of the line. So it is necessary to add some impedance matching network between the line and the load. So one of the impedance matching is to use the open or short circuited stub. It is known as stub matching. A stub of suitable length is connected in parallel with the line at a certain distance from the load. So stub is also a transmission line. So because of the practical parallel connection of the stub, it is convenient to work with the admittance. So there are two types of stub matching. One is single stub matching and double stub matching. A stub is connected in parallel to the transmission line at a fixed distance from the load. And a type of matching where two stubs are shunted to main transmission line on a fixed distance. So it is double stub matching. So it is the single stub matching principle. The input impedance at any point on a line is given by Zs equal to R0 plus Jx. The input admittance is Ys equal to G0 plus J beta. Then the short circuited stub of beta J beta is connected at that point across the transmission line. The total admittance is given by Ys is equal to G0 where Zs is equal to R0. So thus the line from the source to the point is then terminated in R0. It acts as the smooth line. So these are the design parameters. First one is that the point of stub connection. So it is taken at the distance d from the load and the length of the stub. So the first diagram shows the transmission line circuit and the second diagram is the equivalent circuit. It is given by feed line and the stub and the load is taken as the admittance values because of parallel connection. This is the single stub matching diagram where one stub is used and length of the stub and the distance from the load to be calculated. So length of the stub, it is to be placed d meters towards the load from a point at which the V minimum existed before the attachment of the stub. So it is given by lambda by 2 pi tan inverse square root of 1 minus mod of k square divided by 2 mod of k, where k is the reflection coefficient. It is also expressed in terms of voltage standing wave ratio. And next is the distance of the stub. It is calculated by using plus or minus cos inverse of s minus 1 by s plus 1 lambda by 4 divided by pi, where s is the standing wave ratio and lambda is the wavelength. The stub should be connected at a distance from d measured from either direction from a V minimum nearest to the load. So this is the example problem for single stub matching. A 75 ohm lossless line is to be matched to a 100 minus J80 ohms load with a shorted stub. So the calculate the distance from the load, stub length and SD stub admittance. So first of all we need to change the ZL to admittance and then find the distance. So D is calculated using this equation. So we can see this in the single stub matching using Smith chart. So here the admittance value is calculated as 45 plus J 0.366, and the input admittance is calculated as 1 plus J 0.96, and this is the load impedance value calculated as 1.33 minus J 1.067. So advantages of short circuited stub over open circuited stub. So the length of the short circuited stub can be easily changed, but it is not easy to change in the open circuited stub. So it is a sorting plate at the end. Mechanical rigidity of a short circuited stub is better, and open circuit do not behave like a true open circuit in case of stub. So it poses a fabrication problem. So these are the assessment questions. Thank you for listening this lecture.